everyone. My name is Nur Asnie Ajiha binti Sairahmat. My matrix number is 01DTK22F1042.
My name is Zhi Yao and my matrix number is 01DTK22F1068.
My name is Nur Ain binti Mohamad Zaiki and my matrix number is 10DTK22F1048.
My name is Ahmad Fitri binti Abbas. My registration number is 01DTK22F1069. The introduction of vector and scalar. There are a lot of different mathematical quantities used in physics. Examples of this include acceleration, velocity, speed, force, work, and power. These different quantities are often described as being either scalar or vector quantities. We will discuss what these words mean as well as introduce some basic vector maths. What is a vector? A vector is a quantity that has both a magnitude and a direction. Vector quantities are important in the study of motion. Some examples of vector quantities include force, velocity, acceleration, displacement, and momentum. What is a scalar? A scalar is a quantity that is fully described by a magnitude only. It is described by just a single number. Some examples of scalar quantities include speed, volume, mass, temperature, power, energy, and time. So what is the difference between a scalar and vector? A vector quantity has a direction and a magnitude, while a scalar has only a magnitude. You can tell if a quantity is a vector by whether or not it has a direction associated with it. Vector and scalar in architecture. Vector architecture is a variant of SIMD, single instruction multiply data. A single instruction can launch many data operations. The programmer continues to think sequentially yet achieves parallel speed up by having parallel data operations. Scalar architecture is a method of parallel computing used in many processors. In a superscalar computer, the central processing unit CPU manage multiple instruction pipelines to execute several instructions concurrently during a clock cycle.
I will talk about the formula related to scalar and vector. So the first one, the magnitude of a vector. So to find for the 2D vector, the formula we will use is magnitude equal to square root x squared plus y squared. And to find the 3D vectors, the formula we'll use is magnitude equal square root x squared plus y squared plus z squared. And to find the unit vector, the formula we'll use is u over magnitude of u. The next one, the scalar dot product of two vector formula. So the formula is a dot b equal magnitude of a and magnitude of b cos theta. And the algebraic formula for scalar product is a length of a dot length of b equal to a1 b1 plus a2 b2 plus a3 b3. And the angle between two vector formula is cos theta equal to a dot b over magnitude of a and magnitude of b. So the next one is vector cross product of two vectors. The formula is a times b equal to determinant of 3 by 3 matrix, which is ijk, abc, xyz. The next one is area of triangle and parallelogram formula. The area of parallelogram formula is equal to vector a times vector b, and the area of triangle formula is equal to 1 over 2 times magnitude of vector product of vector A and vector B. And next I will talk about the example of real-life application of vector. So the first one, vector in gaming. Vectors are utilized in the storage of location, direction, and velocities in video games. The position vector tells us how far away the object is. The velocity vector tells us how long time it will take or how much force we need to apply. And the direction vector tells us how we should apply that force. And the next one is projectile. The baseball vector is utilized automatically by players in sports like basketball and baseball. In the end, students either shot the target or threw the ball in a direction at an angle, both of which were accomplished by using their understanding of vectors. In fact, in games like javelin throw, it is necessary to judge the angle that the projectile vector makes with the ground so that the javelin can travel as far as possible. And the final one, the example of real-life application of Scalar. For example, you go to the grocery store to purchase half an avocado for your salad. You place the avocado on the scale and the scale reads 87.9 grams. The scale reads the mass of the avocado, and mass is an example of a scalar quantity. It gives you an idea about how much avocado you're purchasing. Another example of a scalar is distance. Before driving to the grocery store, you zero out the trip meter of your car. When you return home from the grocery store, your trip meter reads 34.5 miles. The trip meter reads the distance traveled by your car. It gives you an idea of how far you travel during your trip to the grocery store. That's all from me, thank you.
So, I will explain about real-life apply of vector and scalar. I have attached the picture that describes rescuers transported the flood sufferer from flooded region to the hospital with a displacement vector PR. Then, from the hospital, they quickly rescue flood victim with the displacement vector RQ. The resulting displacement vector PQ is called the sum of PR and RQ. To find vector PQ, we must go through the path from P to R and then R to Q. So this is the solution. Vector PQ equals vector PR plus vector RQ. So the equation is 2a plus 3b plus 5a minus 2b. So we will get 7a plus b.
To conclude our presentation about the use of vector and scalar in architecture, we can see that it can be used in any fields other than architecture, such as gaming field, sports, engineering, even military, and much more. It is true that vector and scalar are widely used in mechanics and computer engineering. That's all from us. I hope you guys enjoy our presentation. Thank you.